Alright, in this video we're going to look at 4 mixture problems. Though they're all mixture problems containing some percents of some solution, or in this case nickel, each question that we go through, and I'm going to scroll through these as I talk, but each problem that we do, we're going to be finding something a little different in each problem. So we're going to go through all 4 of these. You can pause the video and read a problem. Maybe you can find one similar to what you're doing. But this first problem here, it says how many milligrams of a metal containing 45% nickel must be combined with 6 milligrams of pure nickel to form an alloy containing 78% nickel. So what we have here is we have some nickels. We're trying to combine 2 types of nickel. We have a 45% solution, you could say, 45% nickel, and then we have pure nickel. Pure nickel is 100% nickel, and what we're trying to make, we're trying to combine the 45% and the 100%, which was the pure, to make a 78% solution. Alright, let's look at the amounts. Do we know how much of the 45% to mix? The question says how many milligrams of metal containing 45%. That's exactly what we're trying to find. We're trying to find how many milligrams of the 45% nickel. So we're trying to find that. We'll put X right there. We're trying to combine that with 6 milligrams of pure nickel. Well, the pure nickel is the 100%. We have 6 milligrams of that. And we want to form an alloy containing 78% nickel. Well, the amount that's going to make up this 78% is always going to be the sum of these 2 pieces here. We're going to combine X milligrams of the 45% plus 6 milligrams of the 100% to have a total amount of X plus 6. You add these up. Decimal, we want to convert our solutions or our mixtures to decimals, so we have 0.45. 100%, that converts to 1, and 78% is 0.78. And then in this last column here is where we're going to form our equations. So we want to find the products. The products are going to help us form the equation that we need to solve. Your products, you want to multiply these 2 terms here together. X times 0.45 is 0.45x. 1 times 6 is 6. And then when you multiply this times this is 1 term times 2 terms, so we need to set this up as like a distributive property, 0.78 times both of these terms, so x plus 6. Alright, now since you have decimals, I would recommend grabbing a calculator to help with these computations, but what we're doing is we're combining these 2 things that we have. When you combine 2 things, you want to add them together. We're combining the 45% and the 100%, so we want to add these 2 things together. Therefore, that equation looks like this, 0.45x plus 6. We add these 2 things together, and we want it to equal what we need. We need the 78% solution. We're going to use this expression that we come up with, and we set it equal to 0.78 times x plus 6. And now it's just about solving this equation. So 0.45x plus 6, there's nothing we can do there, so we'll leave it alone for right now. Over here on this side, we need to distribute the 0.78 to both of these terms. 0.78 times x is 0.78x. And then 0.78 times 6, they're both positive. So 0.78 times 6, that's going to be 4.68. And now continue solving this equation. Getting to x on one side, I'm going to subtract the 0.45x from both sides. That way we can get the x on one side of the equation. These cancel out, bring down what you have left. You have 6 equals, and then 0.78 minus 0.45, combining like terms, you have 0.33x. Bring down this, plus 4.68. And now let's subtract the 4.68 from both sides, trying to get x by itself. So 6 minus 4.68 is going to be 1.32, and that's equal to 0.33x. Your last step here is to get x by itself by dividing by 0.33 on both sides. 0.33's cancel. 1.32 divided by 0.33. Look at that, we get a whole number. We get 4 is equal to x. Now let's address what this is actually asking us to do. We got x equals 4. That means that 4 is right there. Let's read the question again. How many milligrams of metal containing the 45%? If you recall, when we first started this problem, I called that x because that's the amount that we're looking for. And the question is asking us how many milligrams of the 45% nickel solution, or 45% nickel, do we need? We set up our equations from this chart and we got x equals 4. Therefore, our answer is going to be, our answer was 4 milligrams of nickel to obtain a, what were we trying to make, a 78%, to make a 78% nickel, whatever, nickel rock, I don't know. But anyway, you solve for x, you got x equals 4. And just a little side note too, how much would this nickel weigh? How much nickel will we have at the end? Well, if we got 4 milligrams here, we have 6 there. What I mentioned here is 4 plus 6, we'd have a 10 milligram solution total once we combine those together. But again, all we had to find was the amount of the 45% that we needed. All right, on to another one. We do have some solutions, but we're going to try to find a different part on this chart. Heather wants to make a 36% acid solution. She has already poured 3 fluid ounces of a 72% acid solution into the beaker. How many fluid ounces of 9% acid solution must she add to this to create the desired mixture? What does she need? She wants to make a 36% acid solution, so she needs that. What does she have? Well, she's already poured some. She poured 3 fluid ounces of the 72% solution. She did 3 fluid ounces. So I filled in the solution and the amount from right there. How many fluid ounces of a 9% acid solution? So we have a 9% acid solution, and we need to find out how much of that do we need to pour to obtain a mixture that is 36%. This one isn't really too different than the last example, except for the x is in a different spot, and that's only because I set my table up. I put the 72% first and the 9% second. So our total solution is going to be 3 plus x fluid ounces, because again, you just add these up to obtain that amount. There will be a problem in a minute where this is going to be a little bit different, but hang on. So our decimal, 0.72. Our decimal here, 0.09, and again, I'm just converting these percents to decimals. And this decimal here is 0.36. If you recall from the last example, we want to multiply these pieces together to obtain our products, which are going to help us find or solve the equation. So 3 times 0.72, we get 2.16. X times 0.09 is 0.09x. And then multiplying these, very similar to the last example, you want to set up the distributive property. And once you have these products, again, we are combining a 72% solution and a 9% solution to obtain the 36. When you combine 2 solutions together, you want to add these 2 pieces. When you combine something, you add. So again, we want to add, and we want this mixture that we add together to equal this amount right here. So let's set up that equation. Adding these 2 things together, we have 2.16 plus 0.09x is equal to 0.36 times 3 plus x. You could have wrote x plus 3, but it's just what I wrote back here. It doesn't really matter. 3 plus x, x plus 3, that's the commutative property. So let's solve this equation. We got 2.16 plus 0.09x, can't do anything over there. Distributing over here on this side, 0.36 times 3, that gives you 1.08. And then 0.36 times x, that's plus 0.36x. Let's get the x on one side. I'm going to subtract the 0.09x from both sides. Those 0.09x's cancel, bring down what you have left. We have 2.16 is equal to 1.08, and then 0.36 minus 0.09, that's going to be positive 0.27x. Getting the x by itself, let's subtract 1.08 from both sides. 2.16 minus 1.08 is 1.08. This is equal to 0.27x. And then our last step is to divide by 0.27 on both sides. And if we do that, we get, 4 again. Ironic. But we do get x equals 4 for this problem as well. Therefore, what can we say? The question was asking us how many fluid ounces of a 9% acid solution. When we filled in this chart, we were trying to find the amount of the 9% solution. That's why we called this x. Well, we just found it. We need 4 fluid ounces of the 9% acid solution. We need 4 fluid ounces of the 9% solution. And I guess back here, this is kind of driving me crazy. We need, this whole sentence that I was messing up, but we need 4 milligrams of 45% nickel. That sentence just sounds better to me. How many milligrams of metal do we need? We need 4 milligrams of that 45% nickel. That's what we found right there. 4 milligrams of the 45%. That sentence just easier, shorter, and it's just more clear, I guess you could say. All right, this next one. Kristen wants to make 6 gallons of a 34% alcohol solution. That is what she wants to make, therefore that is what she needs. The solution is 34%. The amount is going to be 6 gallons. And what's she going to mix together? She's going to mix together 24% and 64%. So therefore she has a 24% solution and a 64% solution to mix together. We don't know what either one of these are. Because it says how much of each. All we know is that these two things added together need to equal 6. If we call this x, if we need x gallons of this, but yet we want all three of these two things right here to add to give you 6, if we can find this number, we can take 6 and subtract that number to figure out this. Now you might say, I don't understand that. That's confusing. Well, let me throw this at you. If we need 6 in all, suppose we got an answer of 2. If there was 2 gallons of this, we would need 4 gallons of this because these two numbers need to add to give you 6. Suppose your answer for x was 1. If we had 1 gallon of this, we would need 5 gallons of this because we need 6 gallons total. Therefore, whatever two numbers this may be, once we find this number, we can subtract that number from 6 to figure out what we have left. So this one is set up a little bit different because we have x's in 2 spots. It's fine. It's still going to work out just perfect. Let's convert our decimals. 0.24. This one's 0.64. And this one down here is 0.34. Recall from the last example. Products. Trying to find products. So let's multiply. X times 0.24 is 0.24x. 6 minus x times this stuff. This is where we're going to do the distributive property in this problem. And then this last one here, 6 times 0.34, that gives us 2.04. But remember, once you get these products, you're starting to maybe catch on now. These two things here, we are combining these two solutions to make this solution. When you combine two things, you want to add these two things together to make it equal that. So here's what this equation looks like. We have 0.24x plus this amount. And it's going to equal this number right here, 2.04. Alright, so the x's are on the same side, but we still got some work to do. Let's bring down the 0.24x. Let's distribute the 0.64. So 0.64 times 6 is going to be 3.84. Distributing the 0.64 to the negative x, 0.64 times negative x is negative 0.64x, and this is equal to 2.04. And now let's combine like terms. 0.24 minus 0.64, that gives you negative 0.4x. I'm just combining like terms right there and right there. Bring down your plus 3.84. This is equal to 2.04. Now to get x by itself, we need to move this 3.84 over, so let's subtract it from both sides. They cancel out over here. Bring down what you have left on this side of the equation. You have negative 0.4x is equal to 2.04 minus 3.84. That gives you negative 1.8. And then our last step is to divide by negative 0.4. Negative 0.4 is canceled, so we have x equals 4.5. 4.5. So we need 4.5 gallons of what? Since x equals 4.5, the 4.5 is here. We need 4.5 gallons of the 24% solution. And how do we find this one? Since x is equal to 4.5, if you take 6 minus 4.5, that gives you 1.5. Again, notice these two numbers do add to give us that 6 gallons total. So our answer here in sentence form, Kristen needs 4.5 gallons of the 24% solution and 1.5 gallons of the 64% solution. All right, so that's your solution to this one, and now we have one more. So looking at this last one, and it's a little bit different than everything we've done so far too. Emily mixed together 9 gallons of brand A fruit drink and 8 gallons of brand B fruit drink, which contains 48% fruit juice. So out of all that information, we have two things. We have a brand A, we have a brand B. Brand A, it says Emily mixed together 9 gallons of it. That's the amount that she mixed. She mixed 8 gallons of brand B. Well, we can go ahead and find a total right there real quick. The total is going to be 17 gallons. Remember, we add these two together and we can get that piece right there. Let's see what other information we have. Do we know the solution or the percent of brand A? And the thing is, we don't. That's what we're trying to find. Notice right here it says find the percent of fruit juice in brand A. We don't know what percent of brand A we have. However, we do know what brand B is. Brand B is 48%. And the mixture that she needs to make, or what she did make, is a 30% mixture. So this decimal right here, we can't really do anything with that yet because we don't know what it is. We don't know what that percent is. So we're going to kind of skip over that. This one here, this one's 0.48. And this decimal here is 0.3 or 0.30, whichever one you rather write down. When we go to do our products, for right now, let's just do this 9x. Now you might say, okay, well I'm going to stick an x here, but technically these two things are two different numbers. I'm going to come back and hit on that in a second. But really this 0.48 came from converting this percent to a decimal. So let's still do our product here like normal. 8 times 0.48. is 3.84, and then this 17 times 0.3 is 5.1. Now here's the idea though. We're trying to find that percent solution, but since we multiplied these two things together, we took this number times a decimal to get that number, we took this number times a decimal to get that number. Really this x that we're going to find is going to be a decimal. So remember, we want to get back to here, but the x that we're going to find in this equation, keeping everything the same, amount times a decimal, amount times a decimal, amount times a decimal. We're going to get a decimal here, but notice the question does say find the percent of fruit juice. So we'll come back and address that right here in a minute. It still works the same way once you get this far though. You're combining these two things together, so you want to add them and you want it to equal that amount right there. So when you think about this equation is actually pretty quick to solve compared to some of the others. 9x plus 3.84 is equal to 5.1. All right, solving this equation, let's subtract 3.84 from both sides. 3.84's cancel over here. We have 9x is equal to, take 5.1 minus 3.84, and we get 1.26. And now let's divide by 9 on both sides. So 1.26 divided by 9, we get 0.14. Like I said, we're going to get a decimal for that, and the reason why I moved the x over here again is because when we obtained these numbers here, we took the amount times a decimal, the amount times a decimal. So I really moved that x over here to the decimal spot, but remember, we want to find the percent. Well, all we have to do to convert this decimal to a percent is move the decimal 2 places to the right, so we want to have a 14% mixture of brand A. That is what Emily needs, or that's what she used. So Emily used a 14% solution of brand A. That's our answer to that one. And again, that one's a little tricky because of the fact the ones we've done up until now, the first three, we were finding some type of amount, but here we had to find the actual solution. So be careful with it. And now I just want to point out something now that we've done several of these problems. Look at every time we have one of these problems here, the 78% that we're trying to obtain, notice 78 or for all these problems, this thing that we need always falls between these two percentages. If it were to fall above or below, it would be impossible to make that percentage of solution every time. Like right here, for example, 2. If you saw the video earlier, I did go back and fix this sentence and then re-recorded part of the video, but it'll be okay. Notice here the 36%, that falls between these two numbers. The 34% that we tried to obtain, or that we did obtain, it fell between these two numbers. And then the last problem that we did, we found the 14%, notice 30 falls between those. And something else, so like I said here though, if we had a 14% and a 48%, and suppose we wanted to obtain a 80% solution, it's impossible. You can't obtain a solution any higher than 48%. You can't obtain a solution any less than 14% by mixing these two things together. You can only obtain solutions that fall between these two amounts. Something just, maybe to help you understand this on another level. And to pile on top of that a little bit more, let's find one that was where the amounts were drastically different. For example here, these two amounts here. So I just mentioned that 34%, that whatever you're trying to make, it's going to fall between the two things that you're mixing together. We could never make anything higher than 64% or anything lower than 24% using these two solutions. So we did make something in between it. And now let's talk about these amounts to maybe help you understand this on a little bit higher level, I guess. What is 34% closer to? Is it closer to 24% or 34%? Whatever percent that is closer to, 34% is closer to 24%. That is why we ended up using more of the 24% than we did the 64%. I guess you can say we're trying to dilute the solution down closer to this number since we wanted a number here that was closer to this. Let's look at another one that's a pretty big difference between them. Those are pretty close. 4 and 6. Pure 100% and 45%. We obtained a 78%. What is 78 closer to? 78 is closer to 100 than it is 45. That's why, since 78 is closer to 100, we're going to use more of the pure, the 100% nickel in this case, than we did the 45% nickel. And again, that's because the solution we're trying to obtain is closer to this number than this number. If that's a little bit weird or vague, it's okay for right now, but maybe some of you can grasp that. That's good if you can. If not, it'll be okay. It's not the end of the world. But just throwing some things out there, several examples of mixture problems here. And that's it for this video. Hope it helped.